it's a vertical cut. But then we also have the bottom down here, which starts an incline at this point and comes to the bottom. You see the start of it right here. Okay, so this little section right in here is what's been removed on that, which was down here. And then you had this hidden line,
And where was it removed here?
represented here. This back corner is gone.
Oh.
And it's where this inclined plane intersects this inclined plane. And that's been removed. I don't know that the isometric on this is really going to show you a whole lot. The isometric, kind of everything lines up on it also, but let me try and get this to where it displays at the same place. Do it this way.
There is no way I could have pictured that.
Yeah, that's.
Okay, so there's the object. Right here. Or this is that front inclined plane. Here's your bottom one. And then the back one's kind of hard to see, but it's going back that way too.
Is that, is this one straight or is this is over here and then over? It's not straight. Well, that plane comes
No,
over.
it breaks. Then this is coming from here to the back, and then we're following that inclined plane.
Very weird.
That's just not a cool diagram.
That one's intense.
It's a really mean piece of geometry.
It's intense, yeah. I mean, I think you put it right.
It is.
But
It's a
yeah,
lot.
I was very,
I
very
was like,
pleased with how you folks attempted it. In fact, I even had a few of you get it right. So congratulations on that.
Wasn't me.
Any questions on those? Do you want, any questions on where these projected lines
Maybe.
come from? Okay. Okay then, let's move to the other part, number 5. Let's make sure we're all straight on this. Please stop me if you have any questions. We can go to the text and kind of make sure we're all clear on these conventions and standards. Number 5, the glass box enables the drafter to accurately describe the geometry of a 3D object by showing, the correct answer here is C, 2 dimensions per view for 6 views. Okay, number 6, when viewing the profile plane projection, you are looking at, remember the profile is right and left views, so this would be depth and height. Number 7, when viewing the horizontal plane does which views?
Height and tall.
Yeah, top and bottom?
Oh, wait, width and depth.
Yep, so width and depth. Number 8, which of the following groups of views are related? Remember the definition of a related. 2 views which are adjacent to the same view and share a common dimension. Correct answer here is F, because B and D. So B, the top and right views, they're both adjacent to the front, they both share depth. D, left and right views, they're both adjacent to the front, they share height. Number 9, rounds are defined in the text as external rounded corners. B, fillets, interior rounded corners. Number 11, the intersection of rounds or fillets with cylindrical surfaces form runouts. B. And then on 12, which of the following is not a viewing plane? So A, D, E, and G should have all been chosen.
I was just going to be mad.
So B, C, and F are our 3 projection planes, 2 views per projection plane. 13, libertarians that a drafting technician might take to make a drawing easier to read are conventions. I really don't care much about easier to draw. I really think we take on whatever we can to support people. whether it's hard or easy. But that's as the text defines it. 14, brought out the 3 C's. I'm glad to see, I believe almost everybody in the class got this. These are the 3 overriding principles of every drawing, folks. And I think some of you are finding out now that we're putting these guidelines, these rules, and they're not all inclusive. They can't be, because we have no idea what type of geometry we're going to be drawing on a day-to-day basis. But they get you started. And at some point in time, we always come back to the drawing must be clear, must be concise, must be complete. And then we had our decimal to equivalent fraction to a decimal on this case. Expect these, a few of these questions on every test we do for the rest of this semester. Okay. Like I mentioned about a month ago, these really, I think if you spend some time, they ought to be gimme questions. They ought to be considered bonus questions. Okay. But they will be on pretty much every test we do for a while. Any questions on those? Is everybody okay with the rounding that you do in construction math?
Forget about it. I always round, regular round.
Should we go over that again? Okay.
That's my bad.
Okay. So first off, when we round in construction math, keep in mind where our number line is. We were always taught 5 and above, we round up. Okay? So when we had 5 or above, we rounded up. But 5 is exactly in the middle. It's just as accurate to take that and round down. They're both just as accurate. They're equal. Okay, so what we then do in construction math is we say, okay, well, if they're both equal and I'm just as accurate either way, why don't I do it to where I can help my people in the field? They don't have calculators with them a large part of the time. They can do math in their head. And so what we need to do is we need to get even numbers, because even numbers always are divisible by 2, right? If I have odd numbers, then they aren't, and I'm going to end up with another fraction or some component of that. And so what we look at is the number before. So if I have a round deal like this one, okay? So we all know now that that's 7/16. Okay. Well, the thing we've got to watch out for is if we're doing a 7/16 inch drawing, or a 7/16 inch hole, we need to describe it. We look at the accuracy of the drawing. Because if I put 4 decimal places on a drawing, folks, I'm probably right then and there saying there's only 1 or 2 firms in Twin Falls that can even build this. Because we're going out to 10,000th of an inch. And to get to 10,000th of an inch, you are CNCing, you're probably controlling the humidity and the temperature. Your stuff, you can't be pulling metal out of a yard sitting out there that's frozen and bringing it into the shop and build this thing. You can't do it, because it'll change shape on you. And in fact, if I've got a plant floor and I've got a stamping machine on one side of it and I'm trying to lathe 100 feet away, those vibrations are coming in. I can't build that by hand. I can't do it. Okay, so what I probably have done is I've taken that stamp machine, I've isolated it, I put it on maybe a 10-foot footing that's 10 foot deep to dampen all that. But that's a significant cost to get to these number of decimal places. But we're still 7/16. So we look at that and we say, okay, well, I'm going to go to 2 decimal places because the part doesn't require this level of machining or whatever the case might be to build. So if I say, you know what, I'm going to go to 3, because now I would go to maybe 10 firms in the Twin Falls area that could build that. Maybe I'll go to 2 decimal places. Now I'm getting away, I don't need computerized machinery. Okay, I can go to 2 decimal places by hand. Okay, I get to 3, you can still do that by hand, but it's pretty tough. You gotta have a pretty skilled person and a pretty nice piece of machine that you're covering. So what we always do, so if I'm going to 3 places, okay, so I'm gonna end up here. I look at the one I'm trying to get rid of, it's a 5. So I'm saying, well, I can go to a 0 or, well, I can go to, from here, I can go to 0 or 10, right? Either way. Just as accurate. So why would I take this and go to a 7? Because now I've got an odd number that's going to divide. Why not just take it and go to the even number? So I look at this number right here, it's odd. Well, I'm always going to round that to an even number. Because now somebody can do this in their head. Now this one follows our rules, right? 5, I'm rounding up. What if we get something where we've got to round down? So 1/16, what's that equal to? 0.0625. Now here's the exact same case. 4 decimal places, we're going to go to 3. This one, I'm going to round up to the 10. This one, it's a 5. I can either go to the 0 or I can go to the 10. Well, I look at the number before. If it's odd, I round up. If it's even, I round down. Okay. So this one's going to round to 0.062. They're both just as accurate. They're both off by 5 10,000ths. But now I can do that math in my head on both of them. That's in essence why we do this. So you always look at the number before. Say I'm rounding to 3, there's an odd number, this is a 5, I'm going to round it to the even. Look at the number before, it's even, that's a 5, I'm going to round it to the even number. Now, all the other rules are just like you were taught all through math. Okay? So if I take this guy, 4375, and I round it to 2, okay, this is above a 0.5. This goes to 0.44, right? So that's all the same. I don't know if that clears it up, but those are the two cases we look at. You always round to the even number if it's a 5. That's the way you do it.